these are the answers to Unit 1, Topic 3, Algebra 1A exam review. I wanted to just start with showing again the formula sheet. You will be given this on the exam. You will always want to use it if you ever need help with anything. I also emphasize that you don't need to, spend your time when you're studying memorizing these formulas, but you do need to make sure that you understand how to use them. Also, another reminder, a calculator is permitted on the Algebra 1A semester exam, so please don't forget yours. All right, question 16. Which of the following expressions is equal to 5 to the power of 2x? Well, remember, we can change any base into its equivalent smaller form. So 25 to the x can be changed. 25 is the same thing as 5 squared, and that's to the power of x. Well, with our property of exponents, with our property of exponents, when we have a power, we can multiply those powers, so 5 to the 2 times x, and we're going to get 5 to the 2x. So we know from this that it's going to be a. But let's just look at b and c. b is 10 to the power of x. I cannot make that into a base of 5 because my 5s are 5. 5 to the 0th is 1, 5 to the 1st is 5, 5 to the 2nd is 25, 5 to the 3rd is 125. There's no way I can make that into 10. Same thing goes for C. I can't make 5 into a base of 2. Another way to do this problem is to pick a value of x. And I don't recommend you pick 0, and I don't recommend that you pick 1, just because sometimes those numbers can give you false positives. But let's say x equals 2. If we look at 5 to the 2x power, we see that that's 5 to the 2 times 2, which is 5 to the 4th. And 5 to the 4th equals 625. So that's what we're trying to get this to equal. So looking at A, we have 25 to the power of x, which is 25 squared. You can use your calculator. Remember, this caret button is your exponent button on a TI-83, TI-83 plus, TI-84, etc. So 25 squared is 25 times 25, which is 625. So this further proves that it's A, but let's look at B and C. So 10 to the power of x is 10 to the power of 2. And we know that 10 times 10 is 100. So we know that B doesn't work. Same thing with C. 2 to the 5x power is 2 to the 5 times 2, which is 2 to the 10th. That's 2 times 2 times 2, 10 times. And if you use your calculator, you'll see that you get 1,024, which is also not equal to 625. So again, our answer is A. Vlad wished to solve the equation 64 to the power of x equals 16 to the power of x plus 7. There are many correct ways to solve this equation. Which of the following is not a correct first step in solving this equation? Well, if we look at A, so this one I'm not going to do much math, but if I look at A, I see that I have 2 to the power of 6x. That's the same thing as 2 to the 6th to the power of x. So I want to make sure, does 2 to the 6th equal 64? And according to my calculator, it does, so that works. Additionally, I see 2 to the 4th right here, and I want to make sure that it equals 16. So 2 to the 4th is 2 times 2 times 2 times 2, which equals 16. So A works. Remember, we are looking for which of the following is not a correct first step. So looking at B, I see I have 4 to the 3x. So I want to make sure 4 to the 3rd equals 64. Well, 4 times 4 times 4 is 64, so that works. 4 to the 2 to the power of x plus 7, I want to make sure, does 4 squared equal 16? 4 times 4 is 16, so B works as well. Now when we get to C, we see that it's 16 to the fourth power. And that actually equals 65,536. We want it to equal 64, but it doesn't. So C is not going to work. We see on the other side that 16 to the x plus 7 power stays the same. So that side works, but because of this, C is our answer. Okay, state whether each statement below is true or false. Justify your answer. So your justification can be in words or showing all your work. I'm going to show all my work, but if you want to write it in words, you just explain what you're doing. So I can look at this in a couple of ways, but what I'm going to see is I've got 3 times 5 squared. Now in PEMDAS, remember PEMDAS. PEMDAS says we do exponents before we do multiplication. So I'm going to have 3 times 5 squared, which is actually 25. And 3 times 25 is 75. So I know that this side right here equals 75. My question is 15 squared equal to 75? Well, 15 squared is 15 times 15, which is 225. So 75 does not equal 225. So this has to be false. 9 to the 8th divided by 9 to the 10th equals 1 over 81. So we have 9 to the 8th divided by 9 to the 10th. And one of our laws of exponents says if we have the same base, we keep the base, and if we're dividing, we subtract the exponents. Well, 9 to the 8 minus 10, that's the same thing as 9 to the negative second power. And every time I have a negative exponent, I take the reciprocal of that and make the exponent positive. So 9 to the negative second equals 1 over 9 squared. Well, 9 squared is 81, and I've got 1. So does 1 over 81 equal 1 over 81? Yes. So this must be true. Now we have 5 to the negative second times 5 to the third. When I'm multiplying and they have the same base, with division we subtract, with multiplication we add. So this, keep the base and add the exponents. Well, negative 2 plus 3 is 1, so we get 5. On the other side, we have 1 over 5 to the 6th. And 5 to the 6th is 15,625. So does 5 equal 1 over 15,625? No, it does not. So this must be false. And finally, we have 4 to the negative first to the third power. And we want to see, does that equal 1 over 64? Well, when I have a power, the rule says I keep the base and I multiply the exponents. So 4 is my base and negative 1 times 3 is negative 3. Well, when I have negative exponents, I take the reciprocal and I make the exponent positive. Finally, I have to find out what 4 to the third is. And 4 times 4 times 4 is 64. Therefore, 1 over 64 does equal 1 over 64, and this must be true. Please remember, you need to know your laws of exponents in order to be successful in this unit. You will not be given those on the exam, so those are important ones to memorize and understand before you take the test. For our next problem, number 19, at the beginning of the year, Jared began collecting comic books. He started with 1 comic book. So 0 months, he started with 1 comic book. At the end of each month, Jared had 3 times as many comic books as he had the previous month. So we can see that we're multiplying by 3 to get each next term. 8 months later, All right, so at 8 months later, Sally decides to collect comic books. At the end of each month, she has 9 times more comic books than she had the month before. So the first thing they want you to do is complete the table with the number of comic books that Jared and Sally have. So you're just going to, let's start with Jared. We see that 1 times 3 is 3, 3 times 3 is 9, 9 times 3 is 27. So use your calculator. 27 times 3 is 81. 81 times 3 is 243. 243 times 3 is 729. 729 times 3 is 2,187. 2,187 times 3 is 6,561. 6,561 times 3 is 19,683. And 19,683 times 3 is 59,049. With Sally, we have 1 times 9 is 9, and 9 times 9 is 81. So now we've completed the table. After which month will Sally, so they've underlined it, that's a key because we're talking about Sally, which is right here. So after which month will Sally have 6,561 comic books? One way to do this is you can set up an equation and solve. But honestly, I'm just going to continue my table. So I've got times 9. 81 times 9 is 729. And 729 times 9 is 6,561. So after 4 months, because remember, this is month 0, so this is month 1, 2, 3, 4. After 4 months, Sally will have 6,561 comic books. Another way to write this, although I don't think it's as good an answer, but it definitely works, is to see that we've got 1 and 2 places after our last column at 10. So you could say after 12 months, but you have to be specific. After 12 months after Jared started collecting. I'm going to run out of space, so I'm just going to write collected. Sally will have 6,561 comic books. So grammatically, this isn't the best, but you understand what I'm saying. So 4 months for Sally to collect that many comic books, or 12 months after Jared started collecting. But I don't really know why you would actually write this. I think this is a much better answer. And to show your work, you can just continue on the table. The next question is let M represent the number of months after Jared started collecting comic books. So here M is 1, here M is 2, here is M is 3, M is 4, etc. Write an expression for the number of comic books that Jared has after 3 months. Well, because we're multiplying by 3 every time, that's our rate of growth, and that is going to be our base. And we're going to put it to the exponent of m. So our expression is 3 to the power of m. For D, they want you to write an expression for the number of comic books that Sally has after m months. Remember that m represents the number of months after Jared started collecting comic books. Well, we know that she's increasing by a rate of 9, so we know that that's going to be our base. However, it's not going to be 9 to the mth power, because if m is 1, we're talking about up here, and Sally hasn't started collecting books yet. So Sally starts collecting books in month 8. So let's say I want Sally's first month. So we want it to be 1. If that's the 9th month of m minus 8 will give me 1. So what I'm going to have is n to the power of m minus 8, so that they can be using the same variable equivalently. Finally, it asks us to determine after how many months Jared and Sally will have collected the same number of comic books. So we want to know, when does Jared equal Sally? Well, if Jared is 3 to the power of m and Sally is 9 to the power of m minus 8, we can set these equal to each other and then solve. But remember, these are exponential equations, and the main rule for exponential equations is to have the same base. Well, 3 to the power of m, I can't change that base of 3. I can't make it any smaller. But can I make 9 smaller? Yes, I can. 9 is just 3 squared. So 3 squared to the power of m minus 8 is the same thing as 9 to the power of m minus 8. And I'm going to put parentheses around this so that I remember that I have to distribute my power to both terms. So we have 3 to the power of m equals 3 to the power of 2 times m, which is 2m, and then 2 times negative 8, which is negative 16. Once I have the same base, there's a property of exponents that says that if you have the same base on both sides of an equation, then their exponents must be equal. So m must equal 2m minus 16. So I'm going to write this up here, and we're going to solve for m. I'm going to take away 2m on both sides, because what I do on one side, I do on the other. This is going to give me negative m equals negative 16. To get m by itself, I have to divide by negative 1, and so m equals 16. We always want to write a sentence at the end, so I'm going to say after 16 months, they will have collected the same number of comic books. Units are important, so it might help to also write months over here, but that's not essential if you have a sentence. For question 20, a scientist is studying bacteria growth. At noon, she puts one cell of Cranicus bacteria in a dish. After each hour, there are 8 times as many Cranicus bacteria as there was an hour before. At 4 p.m., she puts one cell of Bevis, I don't know what it's pronounced, bacteria in a dish. After each hour, there are 32 times as many bacteria as there was an hour before. So question A says, how many Cranicus bacteria will there be at 4 p.m.? My advice is just to make a table and continue the pattern. So if we're dealing with time and number of cells, we saw that at noon, so 12 p.m., there was one cell. All right. After each hour, there are 8 times as many. So we're doing 1 p.m., 2 p.m., 3 p.m., and 4 p.m. So we know that we are multiplying by 8, and 1 times 8 is 8. Multiplying by 8, and 8 times 8 is 64. Multiplying by 8, and 64 times 8 is 512. And multiplying by 8, and we get 4,096. So at 4 p.m., there will be 4,096 Cranicus bacteria cells. All right, how many Bevis bacteria will there be at 6 p.m.? So again, I'm going to make a table. I've got time, I've got number of cells. So this one started at 4 p.m. with one cell. So we're going 4 p.m., we're going 5 p.m., and we're going 6 p.m. So at 4 p.m. there was one cell, and after each hour there are 32 times as many bacteria. So here we're multiplying by 32, and we get 1 times 32 is 32. Multiply by 32 again, and 32 times 32 is 1024. So at 6 p.m., there will be 1024 Bavis bacteria cells. All right. Now they're saying, let H represent the number of hours after the scientists put the Cranicus bacteria in the dish. What does the expression 8 to the power of H represent? Well, we know that 8 is our rate of growth and H is the number of hours. So what it represents is the number of Cranicus bacteria that are in the dish H hours after the first bacteria was put in the dish. Okay, with respect to the number of Bavis bacteria, what does the expression 32 to the H minus 4 power represent? Why is the exponent H minus 4? Well, we know 32 is the rate of growth. So what it represents is, it's going to be two parts to this answer. The number of Bavis bacteria H hours after one cell of Cranicus bacteria was put in its dish. So why is the exponent H minus 4? It is H minus 4 because the first Bavis bacteria cell was put in its dish 4 hours after the first Cranicus bacteria cell was put in. So this explains the answers to C and D of what the expressions we're going to be using and why. So part E says fill in the boxes with the correct exponents. 8 equals 2 to the power of what? We know 2 times 2 is 4. 4 times 2 is 8. That's 3 2's, so 8 equals 2 to the third. 32 equals 2 to the power of what? Well, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And 16 times 2 is 32. So we know that 5 2's multiplied together give you 32. So 2 to the 5th equals 32. Finally, solve the equation 8 to the power of h equals 32 to the power of h minus 4 to determine when the number of Granicus bacteria will equal the number of Bovis bacteria. So, we've got 8 to the power of h equals 32 to the power of h minus 4. When we solve exponential equations, we know that the bases have to be equal to each other before we can set the exponents equal to each other. Well, there's no way for me to make 32 into 8. There's also no way for me to make 8 or 32 into 4, but I know that I can make them into a base of 2. We actually just saw that with part E. So 2 to the power of 3 is going to equal 8, and that's going to be to the power of h. And 2 to the power of 5 to the power of h minus 4 is equivalent to 32 to the power of h minus 4. So by power of a power, we can multiply our exponents. So 2 to the 3h equals 2 to the, and remember, you want to put parentheses around this, to the 5h minus 20, because I need to distribute it. Now that my bases are the same, I can set my exponents equal to each other thanks to one of the properties of exponents. And I have 3h equals 5h minus 20. To solve, I'm going to take away 5h on both sides. 3h minus 5h is negative 2h. This cancels out, so it equals negative 20. To get h by itself, I'm going to divide by negative 2, and I'm going to get h equals 10. So my answer is, after 10 hours, the number of Granicus bacteria will equal the number of Bovis bacteria. Question 21. Solve the following exponential equations. So our goal is always to have our bases be the same. So I have 3 to the x plus 2 equals 3 to the 7th. My bases are the same, which means I can set my exponents equal to each other. So x plus 2 equals 7. I'm going to take away 2 from both sides. X equals 5. I think it's always a good idea to check, and since you get calculators, the check should be very easy. 3 to the 5 plus 2 equals 3 to the 7th. 3 to the 7th equals 3 to the 7th. So we already know that that's good, but let's just, 2,187 equals 2,187. All right, we solved the problem correctly. 25 to the x plus 1 power equals 5 to the x minus 3rd power. We need them to have the same base. So I'm going to make 25 into 5 squared to the power of x plus 1. And that's going to equal 5 to the x minus 3. I don't need to do anything on the right-hand side because it already has a base of 5. So I'm going to put parentheses around my exponents so I remember to distribute. And 5 to the 2x plus 2 equals 5 to the x minus 3 power. Now that they have the same bases, I can set my exponents equal to each other and solve for x. So I'm going to take away x on both sides, and we get x plus 2 equals negative 3. I'm going to take away 2, and now I'm going to have x equals negative 5. Let's check to see if that's correct by plugging back in. 25 to the negative 5 plus 1, we want to know, does it equal 5 to the negative 5 minus 3? Well, 25 and negative 5 plus 1 is negative 4, and 5 to the negative 5 minus 3 is negative 8. Well, this is the same thing as 1 over 25 to the power of 4. This is the same thing as 1 over 5 to the power of 8. Well, if I figure out what each one of these equals, 25 to the fourth power is 390,625. 5 to the eighth power is also 390,625. So I know that we did this right. Our last problem is 9 to the power of x plus 2 equals 27 to the power of x. They need to have the same base, but I can't make 27 a base of 9, but I can make both of them a base of 3. So it's going to be 3 squared to the x plus 2 power equals 3 to the third to the x power. Again, parentheses around my exponents, and I have 3 to the power of 2x plus 4 equals 3 to the power of 3x. So 2x plus 4 equals 3x, because once my bases are the same, I can set my exponents equal to each other. I'm going to take away 2x on both sides, because I want to get my x's on one side, my numbers on the other. Usually I bring my x to this side, but because there's nothing else here, it's easier to bring my x to the other side. So we're left with 4 equals 3x minus 2x, which is x, which is the same thing as x equals 4. Like before, I'm going to check my answer. So I have 9 to the power of 4 plus 2 equals 27 to the power of 4. Well, this is 9 to the 6th power equals 27 to the 4th power. 9 to the 6th power is 531,441, and 27 to the 4th power is 531,441, which means that they both equal each other, which means that I did it correct. Don't forget, checking is a very important part of all of this algebra, because you can check to see if you did it right or wrong before submitting your exam. And that ends Unit 1, Topic 3 of this exam review.